Welcome back to another exciting edition of Math Notes with Mr. Allen. So here today, we're doing 9.2 Introduction to Logarithms. And no, that's not a typo. We are skipping 9.1. The way they set up 9.1, in my opinion, is kind of pointless, a little bit of a waste of time. So we're just going right to 9.2 for time's sake here. All right, now like it says here, a logarithm is a mathematical operation, just like addition, subtraction, multiplication, division, exponents, square roots, not just square roots, but all radicals in general. Okay, but unlike the ones we just mentioned, well, logs are new to us. Okay, now, like it says here, simplifying a logarithm is simply a way of asking what power makes this work. Okay, so in other words, and I put it in bold with stars around it because this is very important here, your answer to a log question is an exponent. And that's one of the most important things to keep in mind. And we're just trying to figure out what exponent makes this work. Okay, now before we get to this stuff here, we're actually going to jump down. What does a log problem look like? So let's go down to the example 2 part of our page. Zoom in a little bit. And this is what our log problems are going to look like in general. It's going to be something like this. And this reads log of 64 base 8. This reads log of 6 base 36. This reads log of 1 base 13. Okay, so that's how we read these things, log of 1/16 base 4. Then we're trying to figure out what power makes this work. Okay, well, first of all, what power, where's the exponent go? What is the exponent? Well, like we said, our answer is going to be an exponent. Okay, and obviously this is going to give us some answer. That answer is going to be a number, which is our exponent. So if we want to, we can start these problems off by saying, okay, this is going to equal something. So I'm going to put equals x. Okay, and then, well, x is my exponent, but then what's my base? What's the thing I'm raising to a power? Okay, well, like I said, this is log 64 base 8. Base, that's the thing that we're going to be raising to a power. And think, the base is the bottom like it's in the basement. Okay, and then how do I write this thing in a more familiar way? Okay, because log in my equation, I don't really like that. Okay, so then we want to convert this from log form, which is how it was written originally, into exponential notation. And the way we do that is this problem, we want to figure out our base raised to what power equals that number. And that's how we want to write it every time. And that's what it tells us up here. If we have something in log form, we can convert it to exponential form or exponential notation and write it like this without the log. Okay, so the first step to solving a log problem is writing it without the log. Okay, so we had this problem here, log of 64 base 8. Now, an optional thing, you don't have to do this, but I'm going to say, okay, it's going to equal something. And then now I want to convert this to exponential notation. So then it's always my base to my power, so then 8 to the power of x equals that number there. Okay, now this is a little bit more manageable. 8 to what power equals 64? Oh, it's 2, right? It's the second power. So then I can just put x equals 2. And really, we introduced x. We didn't have to put equals x. The answer is just 2. You don't need to have x equals 2. It's just 2. Since we put x here, though, I'll go ahead and put x equals 2. It's not going to be wrong if you put x equals in there. But again, if you know what the exponent is, just put that number, and then you're done. Okay, so some of these you can do in your head. Maybe you can do it in your head from this step. Awesome. If not, maybe put an exponential notation, and then maybe you can see the answer in your head. Great. And then sometimes you'll need to work some problems out. Like on the next one, you'll see we need to do a little bit more work. Okay. All right, so the next one, log of 6 base 36. Now you might be thinking 2, because yeah, 6 squared gives us 36, but this isn't our base. This is our base. So this problem is asking 36 to what power equals 6. Okay, now, if you're thinking, well, it's a 1/2 power, awesome, you're on the right track. But let's see, how do we show our work for this problem? Okay, so let's see. First of all, this is going to equal something. I'm going to have some answer, so I'm going to put equals x. And then I want to put this in exponential notation. I'm going to work out to the side a little bit here. That way I have more room to work down. Okay, so putting this in exponential notation, it's my base to my power equals that number every single time. So then this is asking 36 raised to what power equals 6. Okay, great. Now we've got an exponential notation. Good, no more log. Okay, but then how do we solve something like this? Now, if you can't see the answer right away, then what you want to do is get a common base. I can write 36 and 6 as what number raised to a power? Well, 6 raised to a power. Okay, let's see, this is 6 to the first. That's fine, that's already 6 to a power. And then instead of 36 raised to the power of x, how do I want to rewrite 36? Well, as 6 raised to the second power. So instead of 36, we're going to replace that with 6 squared. Okay, because that's an exponent there. Maybe I should have put a little bit higher up. But again, we want to write both these numbers as something raised to a power, and we want to have the same base. Okay? And then now that I have 6 to the second power raised to the power of x, what do we do when we have parentheses between two numbers? In other words, what do I do when I have a power raised to a power? We multiply. So then this is 6 to the 2x equals 6 to the first power. And then let's see, if I have 6 to a power and that equals 6 to a power, then what has to be true? Well, then my exponents have to be equal. This thing has to be equal to that thing, right? Because in order for this statement to be true, in order for these things to actually be equal to each other, this has to equal that. Okay, so then now we don't cancel them out, they don't disappear, but we could ignore the bases, and I just want to focus on the exponents. I know that 2x has to equal 1. Okay, so let's see, to get x by itself, divide both sides by 2, and I get x equals 1/2. So then this is my answer. And then just check, does that make sense? If I stick in x is 1/2 here, does 36 to the 1/2 power equal 6? Well, yeah, because hopefully you remember that anything raised to the 1/2 power, that's the same as the square root. Okay, remember, with these rational exponents, the number on top is the power I raise it to, the number on bottom is the root I take. So I'm going to raise 36 to the first power and then take the second root. So in other words, that's just the square root of 36, which, yeah, that is 6. Okay, so our answer is 1/2. And again, if you can know, when you look at this problem, our original problem, which is just right there, if you know that 36 to the 1/2 power equals 6, then great, just write 1/2 and you're done. Okay, it's not cheating if you know the answer in your head, but if you want to show your work, this is how we do it. Okay, so again, the first step to solving a log problem, write it without the log. And then if you can't see the answer, get a common base and then set your exponents equal to each other, and then you're done. Okay, so the better you are with exponents, the less work you have to do here. All right, next, log of 1 base 13. Okay, how do we solve that one? Well, let's see, it's going to equal something, so I'm going to go ahead and put equals x. Okay, and then let's see, how do I put this in exponential notation? It's always your base to your power equals that number. So then 13 raised to what power equals 1. So this is kind of a special case, and we'll see this in our rules later on. But when does something raised to a power equal 1? When we raise it to the power of 0. Okay, so the log of 1, no matter what your base is, it can be 13, it can be 13 million, doesn't matter what it is. The log of 1 is always 0. Because anything raised to the power of 0 is 1. Okay, so this is kind of a special case. You're going to see this one come up often. Okay, so again, anytime you see log of 1, doesn't matter what your base is, our answer is going to be 0. Okay, and then the last one in this section, log of 1/16 base 4. Okay, so again, let's not think too hard. Let's just put it in exponential notation. It's going to equal something. Okay, and then let's see. It's going to be 4 to the x equals that thing. Okay, so then there's our problem written in exponential notation. Okay, and then how do we solve this thing? We don't have a ton of space, so let's just kind of talk it out and see what our answer is going to be. X is going to equal what? Okay, now first of all, my answer is a fraction. So then how do I get this thing to be a fraction? What type of exponent do I have to have? Well, a negative exponent, right? Because when I have something raised to a negative power, we flip it and make it a fraction. So I know it's going to be negative something. And then 4 raised to what power gives me 16? Well, 2. So then my answer is just negative 2. Okay, now again, if we add more space, we can get a common base and do it a different way, but we're just kind of saving space here. Okay, so these are how we solve basic log problems. And if you can do these 4 problems, this is probably about 40% of the unit. Okay, is just converting it to exponential notation and solving a basic log problem. All right, so up at the top here is the section that we skipped. Okay, like it says, and I should have changed it on your notes by now, converting a log problem into an exponential problem. So if we're given something in this form here, the first step is to write it in this form here. Okay, so here they gave us a bunch of true statements. Once we put in exponential notation, it should give us something that's actually true. So this is kind of a weird section to do because there's not really anything to solve, which is why we're doing this second. Okay, because now, yeah, we know how to put in exponential notation, and we just want to make sure we're doing it right by getting a true statement. Okay, so normally we'd get something like the log of 8 base 2. Well, here they're pretty much giving us the answer. They just want to see us put it in exponential notation and then show that, yeah, that's a true statement. Okay, so to put this in exponential notation, remember it's your base raised to your power equals that number. So then this would be 2 to the third equals 8. And then is that true? Yeah, so then we know we did it correct. Let's go over here next. How do we put this in exponential notation? Again, it's always the same. Your base to your power equals that thing. So this would be 4 raised to the power of 0 equals 1. Is that true? Yeah. Okay, great. So we know we did it right. Next, what about this one? Okay, what's the log of 12 base 12? Because again, this is normally the type of problem you're going to get. So 12 to what power equals 12? Well, 12 to the first power equals 12. So again, our answer is always going to be an exponent here. But don't worry about that. How are we going to put this in exponential notation? Our base to our power equals that thing. So 12 to the first equals 12. Yeah, that's true. Great. Let's go to the next one. Our base to our power equals that thing. 5 to the negative 1 equals 1 over 5. And is that true? Yeah, like we just talked about. If we have a negative exponent, we flip it, make it a fraction. Okay, looks good. So again, this is just a little easy practice converting from log form to exponential form. 2 more to go. 3 to the 4th power equals 81. Is that true? Yeah. So then this is how we would write this log statement in exponential notation. All right, last one here. My base to my power equals that thing. Let's see. 1/2. I want the whole thing, not just the 1, which is why I'm putting in parentheses. Raised to the negative 5th power equals 32. Okay. Now again, they're not asking us to solve anything, but is this true? Let's take a closer look at it. Yeah, this is true, because first of all, a negative would flip this, so it would be 2 to the positive 5. And then what's 2 to the 5th power? So 2 times 2 times 2 times 2 times 2. Yeah, that would give us 32. Okay, so again, this whole section was just practicing putting it from log form into exponential notation. And then how we use that, well, that's what we did on the bottom section down here. Okay, let's take a look at the next page. There we go. All right, zoom in a little bit. All right, when you see the word log and there's no base indicated, the base is base 10. Okay, so it's kind of similar to with square roots. If you see this symbol here, what does that mean? Well, it means the square root. So if I, for example, have the square root of 64. Okay, so if I wrote this down, what would the answer be? Well, it would be 8, because the square root of 64 is 8. But what if I put this? Cube root. Well, now it wants something different, right? Okay, right. Now it wants to know, instead of what thing times itself 2 times gives me that number, if I write a 3 here, now it's saying what thing times itself 3 times gives me that number. Okay, now, why didn't I put a 2 here for the square root? Well, basically because we use that symbol so much that we said, okay, we don't want to have to write a 2 every time, so we're just going to agree that if there's no number written here in the index, we're going to agree that it's the second root, the square root. Okay, kind of the same thing with logs. There's a base that we use so much that we said, okay, we don't want to have to write that every time. So if we don't write any base, we're just going to agree that it is base 10. Okay, so when you see something like this, the log of 10, and there's no base written down here, this is the same as log of 10 base 10. This is the same as the log of 100 base 10. Okay, this is the same as the log of 10 to the 5th base 10. Okay, so again, it's just one of those things where we didn't want to have to write any more than is necessary. So if there's no base written, we assume that it's base 10. All right, and then we want to simplify this. Okay, so first of all, this is going to have an answer. So if you want to, this is optional. You can put equals x. And then I want to know, okay, 10 to what power equals 10? And then what's the answer? Obviously, it's going to be 10 to the first power. So x equals 1. Okay, this is asking, since there's no base, 10 to what power equals 100? So 10 to what power equals 100? Well, 10 to the second power equals 100. So my answer is just 2. And again, if you know the answer is just 2, this is all you need to write. It's just 2. Okay, you don't have to, do a bunch of steps. Okay, sometimes it's helpful. Sometimes you don't need to do it. It just depends on how comfortable you are with your exponents. Okay, this one, is asking, well, 10 to what power equals 10 to the 5th power? Okay, now hopefully that was pretty obvious there, and the answer is 5. But again, if you need to, put it in exponential notation. I'm going to have some answer, so I'm going to put equals x. And it doesn't have to be in a different color. I'm just doing that for the notes. And again, if you want to, you can even throw in the base there. I'm going to put base 10. If you want to see everything, that's perfectly fine. Maybe you can't see it because we need to zoom in more. Okay, but if you want to put your base 10 in there and you want to put an x in there, that's perfectly fine. And then how do we put this in exponential notation? Well, it's my base to my power, so 10 to the x, equals that thing, 10 to the 5th. And it's okay to have an exponent there. You don't have to have it multiplied out. It could be 10 to the 5th. That's perfectly fine. Okay, and then let's see, 10 to what power equals 10 to the 5th? Well, obviously, since my bases are the same, my exponents have to be the same, so x equals 5. Okay, and then that's it. Okay, so again, when there's no base written, it's automatically base 10. Okay, because we use it so often. Now, there's one more base that we use really often. It's a special number. It's the number e. So don't think too much about it. What the heck is e? Think of e as being similar to pi. Okay, pi is just a symbol that represents a number that we use a lot with circles. Okay, e is a number that we use a lot when we're dealing with exponents. Okay, just one of those numbers that comes up naturally, kind of like pi does, and it's called, in fact, the natural base. Okay, now since we use it so much, we wanted to give it its own special symbol as well, because we don't want to always have to write this, because like it says down here, the symbol for the natural base is blank, and it is commonly used as what? Okay, so in other words, when it says it's commonly used as blank, what they mean is this. Normally, you'd write something like this, log of something base e. Okay, now instead of writing it this way, we don't want to write log base e all the time. It's used so often that they gave it its own little symbol. So for the natural log, they just do ln, the log natural. Okay, this means log base e. So the natural log of x is the same as the log of x base e. Okay, and I'm not sure why it's always in cursive usually, but that's just how it is. Okay, so anyways, no base written means base 10. ln, the natural log, means base e. So if you wanted to, you could replace this with that. Okay, so like it says, there's a special notation for logs using the natural base. It's just ln, natural log. Okay, it doesn't have to be in cursive, but that's normally how it's written. Okay, all right. So example 4, write the following natural logs in exponential form. Okay, now I'm going to do this on the first problem only. I'm going to convert it to a regular log instead of natural log, and then we're going to not do that on the other problems. Let's zoom in a bit here. All right, so the natural log of 5 equals y. Well, that's the same as the log of 5 base e equals y. Okay, and then they didn't want us to solve. They just said write in exponential form. Well, it's always your base to your power equals that number. So then this here, they just want e to the y equals 5. And then we're done. Okay, we're not solving for y. Don't worry about that. They just said write it in exponential notation. Okay, next. Again, this is the same as log of x base e, but I'm not going to write it like that. We don't want to write it like that. That defeats the purpose of using that shorter symbol. Okay, but again, that's what this means, is the log of x base e equals 7. Okay, so then I want to write it in exponential notation. So it's my base, which is e, raised to my power, which is that number, equals x. And then this one, we actually did solve for x. We got x by itself. X is e to the 7th. Okay, and again, e is not a variable, it's a number. It's kind of like pi. So this is my answer, e to the 7th. Okay. Next, now here we do want to simplify these last two. Okay, so let's start by putting it in exponential notation. And again, if you need to, and we don't need to use a different color, you can start by putting equals x. So natural log of e to the 3rd. Well, that's the same as the log of e to the 3rd base e. So that's my base, which is e, raised to the power of x, equals that thing, e to the 3rd. Okay? Well, e to what power equals e to the 3rd? Well, obviously x has to equal 3. And then we're done. Okay, last one for this section. Natural log of 1 over e to the third. Well, that's the same as the log of 1 over e to the third base e. Okay, well, this is going to have some answer. And then I want to write this in exponential notation. So it's my base, which is e, raised to the power of x, equals 1 over e to the third. Okay, so then what's my answer going to be? X equals what? Well, first of all, how did it become a fraction? How did it flip? What type of exponent do we have to have? -1. And then e to what power gives us e to the third? Well, obviously e to the third power. So then my answer is -3. This would, because here we just want to flip it and cube it. So then -3 is our answer. All right, hopefully this is making some sense. If not, make sure you ask questions when I see you next. And then 2 more examples here. These are a little bit different. Number 6 says find which 2 consecutive integers, which are just whole numbers, the logarithm lies between. Okay, in other words, when we see the log of 29 base 2, the answer to that is, well, 2 to whatever power gives us 29. Okay, and obviously that's not going to be a whole number. Okay, so 2 to what power gives us 29 about? It's between what 2 numbers? So let's see, just kind of keep track on your fingers and, kind of count along with me. Just 1, 2, 3. 2 to the first power is 2. That's too small. 2 to the second power is 4. That's too small. 2 to the third power is 8. That's too small. 2 to the fourth power is 16. That's too small. 2 to the fifth power is 32. That's too big. So then it's going to be between 4 and 5. Okay, because 2 to the fourth power was too small, 2 to the fifth power was too big, so then my answer is going to be, 4 point something. Okay, and we don't know exactly what it is, we just know it's between 4 and 5. Okay, so that's all they want for that one there, is what's the answer about. Okay, and then the last one, find the y-intercept of the function. So it doesn't matter if your y-intercept, if you're looking for the y-intercept of a line, a parabola, log function, radical function, whatever, how do we always find the y-intercept? Well, we always plug in x is 0. Okay, so then here, we've got y equals something minus 1. Okay, and then I want to stick in x is 0 and then simplify this thing. Well, if I stick in x is 0, what do we get here? Well, we get the log of 0 plus 9, which is 9, of base 3. Okay, and then one of the most important things to keep in mind is, what is this whole part? Well, this is just some number. What number can I replace that with? Okay, well, what is the log of 9 base 3? In other words, 3 to what power gives me 9? Well, 2. So then I can replace this whole thing with the number 2. So then I get y equals 2 minus 1, which is 1. Okay, so then my y-intercept for this one is at 0, 1. And that's my answer. Okay, so just like in every other section, if we're trying to find the y-intercept, stick in x is 0. If you ever want to find your x-intercept, plug in y is 0. All right. Hopefully this made sense. If you have questions, please ask me in class.